Hey everybody, hope you're having a great day today. If you did not get a chance to finish the 10.1 to 10.2 benchmark assignment, please do so as soon as you can. I will release the scores later today. Last time I checked, they were really good, so good job to everybody. And today we're going to start on section 10.3. 10.3 starts off pretty simple. Today we're just going to focus on the easy part, and then tomorrow we'll get into the more difficult stuff. So we're talking about solving radical equations, basically. So we're using inverse operations to radicals. So the inverse of taking the square root of something would be to square it. Kind of like when we're solving quadratic functions by taking the square root. When we had something squared, we took the square root. So now it's just the opposite of that. We have the square root of something, so we're going to square both sides. So this is the logic to why it works. It says if two expressions are equal, then their squares are also equal. So if a equals b, then a squared equals b squared. All right. So it says solve each equation. So we have the square root of x plus 5 equals 13. So in order to solve this, what we would do is we want to do inverse operations. Remember, we're still doing SADMEP. So in all the operations, the equations that you're solving, no matter what kind of equation it is, you're always following SADMEP, which means you're going to undo any subtraction and addition first, then any division or multiplication you see, then you'll undo the exponents and then the parentheses. The square root sign falls underneath the parentheses, or the exponents really, but you want to do all this stuff first. So we're going to take care of the square root of x. So we're going to need to subtract 5 from both sides, and we'll get the square root of x equals 8. Now we want to do inverse operations. So what's the inverse of taking the square root of something? Well, that would be to square both sides. So if we square both sides, that'll cancel that out, and we'll be left with x equals 64. And just like any equation, you can plug 64 back in and see if it works. The square root of 64 is 8. 8 plus 5 is 13. I know I did it correctly. So for this problem here, if we look at it, the first thing we want to do is we want to get rid of this 3. So we will subtract 3 from both sides. Then have negative square root of x equals negative 3. Now, if this were just the square root of x equals negative 3, well then that would mean there's no solution, because the square root of something will never be negative. But we still have this negative sign in front of here to take care of. So the first thing we have to do is we have to divide both sides by negative 1. We then have the square root of x equals 3. Now we want to do the inverse of taking the square root. So we square both sides, and x equals 9. Plug it in to check your answer. 3 minus the square root of 9 would be 3 minus 3, which equals 0, so we know we did it correctly. So why don't you guys try these 4 out, pause the screen. When you're ready, press play, and we will see the answers come up. So the first thing we're going to do for this one, all we can do is do the inverse of the square root, which is square both sides, and we get x equals 36. For here, we want to add 7 to both sides first. And we get square root of x equals 10. So you're asking yourself, the square root of what equals 10? Well, if we square both sides, we'll find out. That would be 100. For this one here, if we subtract 15 from both sides, get the square root of y equals 7. So if we square both sides, we get y equals 49. And then for number 4, if we subtract 1 from both sides, get the negative square root of c equals negative 3. And we divide both sides by negative 1. Square root of c equals 3. So Remember, it equals a positive, so we know there's an answer. If it's equal to a negative, there'd be no solution. But we will just go ahead and square both sides here. Canceling that out, and C equals 9. All right. So, if there's any questions about this, make sure you please write it on the Google Doc. Got one more example to try here. Now, if we have a radical on both sides, what we would want to do is we want to get rid of the square root sign. So there's no other operation to do. I know there's a bunch of adding and subtracting. There's some multiplying going on. So I know you want to undo these things, but we can't because they're both inside the radical signs, which are technically considered parentheses. So first we have to take care of the parentheses. So we're actually all the way at the parentheses side of the SADMET. So we're going to square both sides. And when we do that, we're going to have 2x minus 1 equals x plus 4. Now we'll go ahead and solve. Subtract x from both sides. We get x, add 1, equals 5. And as always, you can plug it and check it out. That would be the square root of 9, which is 3. This would be the square root of 9, which is 3. So we know we did it correctly. For cube roots, it's the same idea, except instead of squaring both sides as the inverse operation, you're going to cube both sides as the inverse operation. So if I have the cube root of 5x minus 2, to do the inverse of that, I would cube both sides. That would give me 5x minus 2 equals 1728. All right, and then we will add 2 to both sides. And you get 5x equals 1730. Let's see, 5 goes into 17 3 times. So that'd be 300, 230 left over. 46, 346. So x equals 346. All right. So if you're all set for these, if you could just go on to this screen here and try these 3 out, pause your screen, and when you're all set, press play and you will see the answers come up on the screen. All right, for this one, we'll subtract 7 from both sides. And you get the square root of x plus 4 equals 4. We square both sides here. You get x plus 4 equals 16. And then x would equal 12. For this one, you square both sides. Do the inverse operation of the square root, and you would get 3x plus 1 equals 4x minus 7. Then when we solve, you subtract 3x from both sides, add 7 to both sides, you'd get 8 equals x. And for this one here, we'd add 4 to both sides. You get the cube root of y equals 5. So you cube both sides, and y equals 125. All right, so those are our 3 answers. So if you have any questions on those, please let me know. And then one thing that I just didn't see on here, you know, if you have the square root of anything, like let's say we had the square root of x plus 8 equals 4, right? Well, when you subtract 4 from both sides, you'd get the square root of x equals negative 4. So if you got to a problem like this, make sure you just notice that if you have the square root of x equaling a negative, it means there's no real solutions because you can't have the square root of something equal a negative. So obviously if you square both sides, you get x equals 16, but that wouldn't work. So just take note that if you ever have the square root of something equaling a negative, once you isolate the radical sign, the square root sign equals a negative, it's no solution. If it's cube root, it's okay because the cube root of something can be negative. It's just the square root of something cannot be. All right, so if you're all set on that, please go to Big Ideas, answer those questions that are there for today. And again, if you have any questions, please write them down in the Google Doc or attend one of the open meets. All right, have a good day. Talk to you later.